So welcome everyone in this today's lecture where we will be covering the fourth stage of the design thinking we call it prototyping. So my name is Vikas Shukla and I am the Innovation Chief at Moonshot Junior. We have been helping many students in not only giving the theoretical knowledge about the entrepreneurial skills and other different skills including software, the app development and other things. But we also actually do the prototyping stages, and the students actually learn from this. And we actually have a prototype development platform that has been created specifically so students can join wires, develop the prototypes, develop the hardware, develop the mechanical enclosures, and also develop the software into it, and thereby actually learn what that prototype looks like. So we are going to learn about the prototype in light of these design thinking process, and I will be speaking from my personal experiences as well, and that's where I think you would be actually getting the insight into the prototyping and what it actually means. So let's start with asking a question of why do we actually need the prototyping? We have an idea, we have gone through the first three stages of the design thinking process, and then we ideated the things, and we emphasized the things, and so on and so forth. But then comes the stage you actually need to have something in hand, something to show off. I mean, so far we could have a business idea of doing something, some product, but unless now it's the time to jump into actually. So why we do the prototype, and what by prototype what we actually mean is a something kind of a, it's not a very finished product, not a final product that we are going to start sending out to sell the customer, but something that we can ourselves be sure we can show that this is the thing, that it's a physical product or a software or something that is working, that we can see how it feels and looks like. So prototype is a very low cost way, or as low cost as possible way to show that something is working. And why we want to do is, in my view, its first thing is that we get a self confidence that I can have something. If I can create something workable thing, I can get the self confidence into it. Another thing is that if you are going to ask for money from the investors and you just present a whole bunch of the ideas and slides and so on and so forth, investors can give a certain value if you have a very good history of previously successful company and so on and so forth. But let's say if you are a first time, you don't have a previous history of creating a company or selling a big company, how do you instill the confidence into the investors? I mean, if you show them a physical product in your hand that you can say, hey, this is how it's working, this is how I have put together, or it could be an app or any software that has at least some level of a website, for example, with some kind of functioning something, or an app, whatever, then it instills a great deal of confidence into the investor, and we know how hard it is to raise the money in the investor. So that's what a prototype creates, a difference between a business and a business plan. Business plan is only as good as you just tell it. Another thing that a prototype does is that if a prototype is not perfect, when we do a prototype, we come across some of these uh, failures, some mistakes, some shortcomings, and that you will notice that you actually would not recover, and then you can make a note of this, that, and then you can actually try to fix those problems into the next iteration, into the finished product, and you go into the same scale. Sometimes the the product that you make looks good to you, it could be functioning for you, but you can present it to some users for their feedback, then you could actually learn about some more mistakes, especially in kind of user interface or GUI could be needing improvement and so on and so forth. So That's another reason why a prototype could be needed to fix that. So failure is a part of the prototyping. You go on improving it, improve it again and again till it gets to the perfection and that. Uh, Now, in terms of what a product, what we mean by product, it could be anything, but a typical in modern day a product could be composed of a mechanical, electrical, or software, or a combination of all these three areas. And the reason you need to look into this as an entrepreneur, you have to expand your knowledge of what this, and that's one thing we do at Moonshot Junior. We give them a skill. So the skills consist of what are those individual items that you need to know about when you want to do some product, and that's where the tech knowledge becomes important. We could be telling them about the mechanical design, we could be telling them about the electrical wiring, at least on the broad level, how the things look like, what do you need to actually develop the electrical part of it, or the software part of it. There are many examples of where a product could need all three parts. For example, a Nest a thermometer that Google's nesting. It has a mechanical part, it has an electrical part, and it has a software, it has an app, all four things. And the reason you need to know all these parts in detail is that you need to collaborate with experts. Either you have the expertise, all three of them, which means that you need to be an expert in mechanical, you need to be an expert in electrical engineering or things, whatever it needs to develop the electronics behind it, and you need to be an expert in software, obviously. You cannot do all three, but you can be aware of what kind of knowledge you need to develop a product, and that's what we do at Moonshot Junior. So now you are not an expert in all those three, but you still need to have a broad knowledge of all these things. So what do you do is you collaborate with an expert. If your product requires mechanical engineering, some electrical engineering, some software, and maybe a one person who is managing those businesses and all these things, you need at least one expert in each of these areas, and then you need to know where and what kind of work you need to take from them. And that's why one of the things that we are proposing, for example, we already have some level of electrical engineering things. We teach them, students, how to do a wiring, how to turn on LEDs, a 7 segment display, or maybe an alphanumeric display. We teach them how to connect a sensor, take the readings from that, and then display on a maybe some kind of display or something. Or maybe we teach them how a sensor triggers an alarm or something like that. So they have at least some idea of the electrical engineering, and that's something I would suggest that anyone which has some kind of curiosity, at least from the curiosity level, they should develop that kind of electrical engineering a concept, or be aware of what that takes it is, or be aware of that such kind of persons could be needed if you are developing that kind of product. You may need some kind of mechanical engineering expertise, and for this reason at Moonshot Junior we are starting a course on the mechanical engineering. You should have some idea of what a 3D design looks like, uh, and then how do you bring up that 3D design prototype. Maybe you need to develop an enclosure, and how do you do a 3D printing so that you can show that 3D printed module in an enclosure their product. So this is how it looks like. And if you don't have that or gain that kind of expertise, obviously it requires a maybe many months or possibly even a couple of years of expertise to finally get that kind of expertise to be a mechanical engineer to design that. But the key point is you should know those kind of expertise, and the third is of course the software thing and so on and so forth. So just to give a very broad idea of what a product development thing looks like. And in each of these areas, again, it needs to go through the process of iteration, improvement, and things like, you can come up with an initial mechanical prototype that may have a misalignment, sometimes the finishing does not look good, so you improve upon that. the same thing could electrical. Initially the things work, but maybe at some extreme corner cases, at extreme temperature, it does not work, or when the power supply range goes out of the range, it stop behaving in a certain way, and then you improve upon the things. Uh, so some of those examples of many of our students in the Moonshot Junior, they have been working on the prototype, and you could see them on the um, on Kickstarter, and then many more are in pipeline. They are actually not only just prototype, but actually a revised and a refined prototype that are going into Kickstarter. So one of them prototype, for example, our Dotty Rose students, they are working is a restaurant reminder, and that product, and I will have this in this video. I will show it in the background of that restaurant prototype, how it looks like. So what it does is this project is when you go to a restaurant and you are sitting waiting for someone, and then you suddenly need a, a glass of water, and you are always looking for someone passing by so you can ask him to stop by and fulfill your order. So the Dotty Rose students, with collaboration with us, and they designed a prototype, or actually a product, where they have a reminder button. You press on that button, and that information goes to a central reception area, and they know which table want the attention, so they can come back and attend that person and ask what do you want. So we started with this product. We gathered together a bunch of this. There were two parts of it. One was this transmitter part that sits on the restaurant, and then there was a receiver part that was at the reception area. So in the transmitter part, we found an NRF module. It's an RF device, and we clubbed it with an Arduino Nano board, wired it together, and we send it out to the Dotty Rose students. And our subject matter expert, they themselves wired these things, and then they wrote few codes, and they added a kind of a button to it. So that you press the button, it sensed that, and it sent an RF code to the central base station with its ID. A very simple thing. On the receiver side, we developed one of our products. This is also available. It's called embedded learner board. I think there are details available about it. So this has an alphanumeric display on the top of it, and then we hooked it about together, wired it so that someone pressing the key, and we hooked an RF receiver with this board, and then when someone presses it, the transmitter side, it comes to this side, it's received by this one, and it displays. So now with this prototype, the Dotty Rose student, they actually learned those things. They were actually able to see something in working. That increases the confidence that we are able to do something by just wiring few things. And then eventually we develop the mechanical enclosure out of it, so it starts looking like a finished product. So and we do not know whether a restaurant could be useful for a restaurant. With that prototype, with a working module, they could take it to a restaurant, actual restaurant, or it could be in a hospital, maybe in an emergency hospital, in the emergency room where patient could be needing sudden attention. They could use it there, or many other places have some kind of use cases that. So what it does is, what this prototype stage did is, even before we bring together a lot of collaborating persons or hire people, we can actually take some of these helps from different and Dotty Rose students took the help from our subject matter experts, and then they took their help, and they did their prototype. They actually learned those things, and also learned the entrepreneurial things. So but this same thing applies to everyone, even if you are doing I saw we had another many different projects. We have a dehydration reminder prototype, in which we added an add-on wrap around a water bottle, which the idea was many people in all over the world, they are dehydrated because they don't drink enough water, that leads to a multitude of health or other problems. And one way to solve is to have some kind of sensor in your water bottle that you carry with you in your office or school. And then when you don't move that water bottle for a certain period of time, let's say 3 or 4 hours, then it sends you a reminder maybe on your cell phone, or locally it gives a buzzer or an alarm or an LED blinking or something like that. So this, again, we created a prototype, and of course it's not perfect. It was not perfect. The students, another batch of the students, they found some problems during the software development phase itself. They had to change something. We had to change some kind of a sensor, whether there's a tilt sensor or whether we need an accelerometer. The problem could be solved in many ways, and we learned it hard way that the tilt sensor is good, but it does not kind of create all solution. For example, we learned that accelerometer, it could be better, but it was complicated to solve. I mean, we could use some kind of AI as well, and so on and so forth. But we eventually leaned upon a tilt sensor, which was simple to use. So, I mean, that's the beauty of this prototype. You could use something simple to show that's the something that is working, and later on you can modify it, you can improve upon it in terms of software, in terms of more sophisticated hardware. Uh, but it does not have any product does not has to be complicated. For example, if you ask about a product like a cell phone development, or even to think about a prototype, you need a big investment. Although you could use some kind of pre-existing hardware and things like that, but of course it's a commodity thing. So um, a cell phone like prototype could be more expensive. Some of the areas, if I want to go into in depth, is, for example, development of a silicon product. For example, just to create a prototype, I mean, you are looking for a $5 or $10 million just to create a prototype, because the silicon development process itself is requires a big investment. But it does not have to be always like that. And you don't have to have all three components in your idea. In many cases, a simple app can do wonders. For example, as I think I was creating in my mind, and I recently started looking at, there could be a simple music app where, for example, if you are learning to sing a music, then you could actually develop an app where whatever note you are trying to practice, it can show a needle that your note is right. And then you can connect with many things. For example, there could be a physical keyboard where you press the keyboard, and it may be sounding something in your headphone, and then you can at the simultaneously you are singing, and then by the pressing of the key, and then by your singing, it could develop something. I mean, there is no dearth of the idea that you could develop upon. It's up to you to where your passion lies, what you are trying to build upon, and that we already saw in the other phases of the design thinking that I'm not going to cover in this one. But in prototyping, you are going to create a simple app, for example, that can do just not the whole key and everything, but just detect your voice, maybe detect its frequency and displays the frequency, and that could be good enough that you are going to develop a full-fledged Android app that will maybe later on develop to show the percentage of the progress, how close you are to the note that you are trying to sing, how many mistakes you make in trying to utter a note, and how you are improving, and so on and so forth. But the initial prototype itself could be as simple as you are singing a note and it's just displaying the frequency. That could be a simpler way. And then once you do that, your investor, or you yourself, or the group of people you are working with, they will need that we have the kind of the capacity, the capability, we have the confidence to develop that app kind of thing. Um, so so some of our own products are, I have 11 different, actually more than 11 when I started working with my students at Moonshot Junior, maybe like 15 or even more, or 20 different products that are either on the Kickstarter or at Amazon, or they are in pipeline. The one of the things, for example, we started with the design of this Moonshot Junior embedded learner board. Um, the key idea in this one was actually a platform itself to teach students learn this different kind of hardware as well as the software. And when we started this product, we first went through the first three stages. That's all, trying to feel what the students could be learning, and the other three phases, more or less, in the design thinking process. And when we created this particular prototype, it turned out it was very close to the actual product that we were shipping. But to give you an idea of what went wrong, and there still are many things that keep improving. For example, more recently, we found that I don't know if you can see these potentiometers that are right here. Um, Let me go with the pencil. This is one of the potentiometers, resistor that people use to adjust the intensity of the backlight LCD, and the other one is used for analog to digital conversion and so forth. So many times students find it hard. It's actually adjusted with a small screwdriver, but the students found it hard because sometimes they will turn this potentiometer and it will simply break. They will either break it, or they don't have that screwdriver. So in the newer version, we are doing two improvements. For example, one is we are using a much bigger potentiometer that we could actually turn it more easily, and then we are supplying them with a very small screwdriver that they could use to turn it. But even and that's the problem that we faced later, after we started shipping this product. Even before that, we found that we had some, our manufacturer, they use the wrong part numbers, and these transistors here, they were mounted incorrectly. So we had to fix it, turn it around. We had other issues. We are supplying, you see this headers here, we are supplying them with the cables were much smaller, and then we actually use it with an Arduino Uno board, and then they found that those cables could not reach, so we used a much longer cable to solve those problems. Uh, Other thing, we used a motor that did not vibrate well. So those are a bunch of the things. But once we brought this in and we had those initial prototype, most of the things were fortunately working. But that's not the case always. I mean, you could always have a bunch of the issues. Um, we develop another product, something we call it as a triple power supply. What you do is you just give it a USB, power it by USB, and then on the output you could get three different outputs. It's still available on our website, the triple power supply. We did not pursue it to much make it any bigger business success, but we could if we wanted to, and this could potentially replace any of the more expensive power supply, bench power supplies that we could be using. So, but again, this also had its own um, challenges in terms of the software, or the accuracy that we had to go through, and I'm not going to go into the details of it. Uh, One of our products had the mechanical as well. For example, this product has mechanical, has electrical parts. Um, Before we do that, I had a product which we could use it with an inexpensive Raspberry Pi Zero board, and we developed a product which we could, I don't know if you are aware of the Raspberry Pi Zero. On the back of it, it has a problem is it has only one USB connector right here. Uh, so, so if you want to hook up any USB, for example, keyboard or mouse, you have to have an external USB um, hub. And the way we try to solve this uh, is to use this spring action pins. So with this spring action, you could see that you just press those um, flex pins, and then this is how it connects to the back of this Raspberry Pi Zero, something like this, and it makes a connection, something like this, if you can see that. And after that, we extend like these two uh, uh, USB connectors. One of them, maybe you can use a mouse and a keyboard, and on that board we have a USB hub chip that you can see here, this black chip right here. And then what we do is we inserted this whole thing into this box, and then what we have is a simple USB camera right here, if you can see that, and that plugs in into a connector right here, this fourth USB port, the simple USB camera. Now what we have is a very inexpensive solution where students could put this whole thing together like this. This is what our simple prototype looks like. It has a mechanical part, it has an electrical part, and probably not so much of the software because it runs on the software. But again, this prototype, we figured out that some of them are misaligned, not properly aligned. We had to adjust this, all this prototyping. So the key idea here is when you do but again, this is still a working prototype that you could improve upon. For example, you could take this prototype to your investor, or you can be confident about yourself. And what we do at Moonshot Junior is not only talk about make a business plan. It's one thing to do a business plan. How do you have a very small amount of money. We are not talking about hundreds of thousands of dollars. You are very limited with your budget, and you still want to create a prototype. It can be in fancy. It could be a simple app. It does not have to be necessarily a very electronics or hardware or mechanical. It could be simple software. But you should be able to take it to the finish line, and to take it to the finish line, you need to start with a prototype, even if it's faulty, even if it's half working, to give a confidence. Once you start doing that prototype, you need to collaborate. We need to find out what are the right kind of people I can collaborate with. Maybe I don't know the programming, maybe I don't know the app development. I need to start looking for a partner who knows programming, who knows an app development. I collaborate with him. I ask him to come in and help me. And once that he sends me a prototype, we start making a working collaboration. We make mistakes, we improve upon, we fix the error, we show it to the investor, and we move from there. And one thing you must note, that this journey is there are going to be failures, and it's completely possible that that project may not see the light of the day as a success. But the key idea is the amount of the learning, the sheer amount of the learning that you derive in doing something right from the ground, and just be able to create a prototype will give a kind of the experience in a year that you probably won't be getting working like 5-6 years in a company or a firm. Because if you are working in a big company, you get only one part of that job, and you will learn only as much as you can get there. So I hope I spoke from my experience, what I did, what I teach to my subject matter expert, what I tell them to teach the students at Moonshot Junior. I work with the students who have a lot of energy. They are as young as 13-14 years kids, but they are ready to learn things, ready to create prototypes, and I love working with them. So my advice would be to start looking at, and fortunately this is an opportunity available to us. Um, we have some open source codes available. Start looking into those if you are in a prototype. Start installing some kind of a compiler for software or something, create an environment, take some course, maybe Moonshot, maybe other places, and start learning it. If you have any more questions, just write it in the comment section, then and I would be happy to answer. Thank